My name is Raphae. I work at Odoo for 13 years now. And I'm actually responsible for a server-side framework of Odoo. And so when I was asked to give you a presentation, I thought, okay, we've got actually quite a few frameworks in Odoo, in the product. Those frameworks are essentially the building blocks for all our business code. And the question is, I got often asked, why don't you use framework X, Y, Z? And in my specific case, a large part of our server-side framework is an ORM. And so here I'm going to kind of show you a concrete example. So my talk will not be generic, it's going to be very specific to Odoo itself, and I'm going to show you why for Odoo we have our own ORM and don't we just use any kind of available ORM on Python. There's quite a bunch of them, and some of them are very, very nice. But this one, somehow, it was developed in-house, and it has some features that the others don't, and that are beneficial for our business, in fact, for our development. So the framework in Odoo, so Odoo is a product as such, and as a code base, it's essentially an ORM, and it's an API to the database, essentially. It's an applicative framework as well, and it's a kind of a generic user interface. And on top of that, you can build your own business software, anything. The ORM, which is the part from which I'm kind of the specialist in Odoo. I'm the leader of the team, actually, that takes care of the ORM. So the ORM, essentially, it's an API, it's an object API to a database. So we're mapping data models to SQL tables. We're talking about the records in the program that corresponds to lines, or rows, sorry, in the tables, in the SQL tables. And we're talking about record fields. And on the SQL side, those corresponds to the columns in the tables. And the idea is that instead of writing complex SQL, instead we use much simpler operation to say, okay, search for the records that satisfy this condition, read them, get them in memory, access their fields, create new records or suppress them, delete them, and modify them. That kind of a simple operations, and they're written just like regular Python code. The advantage of that API is essentially it makes the code looks like plain stupid object code. And you don't have to be kind of an SQL master in order to be able to do something decently efficient. In fact, you don't have to care at the first, let's say on the first approach. You can really code naively, and actually most of the time it just works. And our code looks like this. So I guess I'm the only one in the presenters who going to show you some code. Developers like code. And this looks like this. So we have things like an operation called search, and we have a funky way of encoding the condition. And we can get some records in return. The records, it's a collection. And so you can, of course, iterate on that collection to traverse all the records, access some of their fields, modify some of their fields, and so on and so on. So you see, the actual Odoo code looks like this. This is Python. We use Python as the programming language. And that's mostly what it looks like. So the question is, why didn't we use like Django, SQL Alchemy, or Pony ORM? It's a funny one as well. Why didn't we use any of those? And the trick is that the very first reason is that the ORM was somehow born a bit more than 20 years ago. And at that time, actually Django wasn't released yet. And it was one of the first ones as a Python ORM. So there was nothing really available on the market. And so it started off as an in-house framework. Then things started piling up on top of that, business code running and so on, so on, so on. And with time, it evolved. And actually, because the framework is actually pretty tied, even though it's got actually, you could isolate it, but it's actually pretty close in our everyday life to the product, Odoo as a product as a whole. We can actually apply some specific trade-offs in the ORM itself, knowing what they give, for instance, in terms of performance, which is one of the most important focus in the ORM, what they give in our concrete cases, our concrete business cases. And our ORM also have a bunch of features which are you usually don't find in other ORMs. And those features, one of them is actually, it makes the ORM much more complex than necessary maybe, but it's helpful because essentially it reduces by an order of magnitude, I think, the amount of code that a developer has to write to make things work. So it's kind of a generic tool that makes many things work automatically. I'm going to show you a concrete example of that. So Odoo as a product or as a framework, actually, it comes with a bunch of generic features. Like we have user accounts and data models for which you can actually tune the access rights you want to give to a group of users. You can say essentially who or which user account can access or perform which operations on what kind of data models. Okay, so you connect groups of users, operations, and data models, and you say who can do what, essentially. And actually, checking those access rights is done not in an entry point. Most applications actually do that as an entry point. That is, you say, oh, I've got a request for doing this on this object, on this business object, and I'm just looking, oh, has the current user the given role to perform that operation, yes or not? And if yes, we just run the code. Here, it's slightly different. It's kind of mixed inside the ORM. And it prevents kind of accidental things from happening. And it's also because, like for instance, if you want to modify a sales order, you can perform a modification on a sales order, which actually also indirectly applies modifications on sales order lines, which may also imply indirect modifications on kind of third-party objects, which you shouldn't be able to modify. So those security aspects prevent attacks, some sort of attacks. And those attacks are made possible without security. They would be made possible because of the flexibility of our API. So the API of the ORM enables indirect modifications of objects. We also have in the application, but actually it's quite built into the ORM itself, support for multi-company. And it's kind of useful if you say, okay, I'm selling products, and actually I have a main company and subsidiaries, and actually some of the products can only be sold by subsidiaries. So subsidiaries may have specific products, and the other companies, so when I'm doing things with the other companies, or as a member of another company, I shouldn't see those products. They're not part of my business. They're only part of one of the company's business. This kind of support is kind of built in to the ORM itself, and so on. if I make a quick comparison with Django, it's also a Python framework. It has a much stronger model view controller architecture. With Python, it's a bit more mixed. Let's say it's less separated. It has many more backends. Actually, we can only support at the time Postgres databases. With the Django, you can connect with MySQL, and plenty of others. And they have many nice abstractions like the query set. Essentially, it enables kind of to build a query and execute a composed query at the very end. We're not that flexible, although we're slowly actually improving the ORM to enable that kind of things. And so if you want a quick comparison, when you write this, that is, you assign a value to a field on a specific record. In most ORMs, essentially this updates the row corresponding to the record. In Odoo, it will check user permissions to make sure the user request does not do something wrong or does not do something that's forbidden for that kind of user. It might check that the value is consistent with respect to multi-company rules, like if you're making a sales order, so you're selling some stuff to some customer, and you're doing, let's say, for the sake of one of your companies, something ensures, the ORM will ensure actually, that in the sales order you cannot put a product that's only available for another company. So it's making sure that you only sell products that are owned by your company and not another company which is handled under the same database, same data set, and so on. So it also updates the corresponding row in the database, of course. And it also has a funky feature, which are the computed fields. And there's a big deal about those computed fields. They're very specific to our ORM, our framework. And I'm going to show you a little bit how they look like and how they work. And then you will be able to figure out the benefits from that. So this looks like this. So imagine you have a data model called a contact. A contact has a name. It has a company. So we use company _ID. That's a database convention, in fact. Essentially, it's a foreign key to another table for the companies. And then, let's say you want to show a label corresponding to that contact, and the label is essentially computed from the contact's name and its company's name. That's what you see in below in the compute method below there. So you say for you've got a self, which is a set of records on which you have to compute the field's value, the value of the field label. And you say for each record.label is, you essentially compose the record.name with the name of the company of the record. That's it. And then you have this depends thing, the decorator, which say, by the way, my field depends on the name of the contact and the name of its company. We'll show you in a moment what those depends are for. So the point is that this computed field does not look like a getter. In fact, in most ORMs, you'd say just use a getter. In Python, it's a decorator called property, and you say just return. So you say return self.name combined with self.companyID.name. What's the advantage of having this formulation is that the point is that it's not just a getter. With a getter, what you get by default is that you will compute it every time you access it. Here, you compute it once, and then you can use it many times because the result is actually stored in some cache. So you compute it once, and then you can use it many times. And when you compute it, the framework will try to compute it not one record at a time, but will always provide you a batch of records on which you might compute it. And the advantage that you can take advantage of the batch itself, because for instance, you have to make a complex search or a complex SQL query, because maybe you're writing actual SQL for this one for some reason. If you have to run that SQL query for every and each record, this will take way more time than having one query for the batch. And then from the result of that query, you can actually get the individual results. So you can take advantage of the batch you're asked to compute to make some performance optimizations. And that's actually built into the API, which enables that. The other thing that's useful is that because you tell the RM what your field depends on, it means that the RM will know when the value you've computed is no longer valid. So for instance, if I take one of those records, I computed the label, the value of the field label is kept in cache, and then later on in the code, business code, the field name is modified on the record. From that point on, you know that the label of that record should no longer be the same. So the value you've computed before is no longer valid. And the RM will automatically call back that stuff at the right time. So I'll explain a little bit what it means at the right time. We'll call that thing to update the value of the label according to the new value of the record name. You see? So it takes advantages. We use caching for having better performance. And thanks to the API, we know when we have to invalidate that cache. And the way it works is essentially, imagine, so when you change record.name, it's obvious. But then when you change the name of some company, which records should you recompute? So what you have is, imagine you have a record on the left-hand side. It has a foreign key to a company, which is a record on the right-hand side. And on the right-hand side, you have a field called name. So you have the field label. It depends on the field name through the foreign key company ID. It's a relation in the mathematical sense. So if you modify the record on the right-hand side, what the RM will automatically do is determine all the records that are linked to that record and depend on the records, the company's name, and automatically figure out that the label of those records must be invalidated and potentially recomputed. This is done automatically. You don't have to care about it. And imagine that maybe the label itself is used as the dependency of yet another computed field. Then you'd have transitive dependencies. The system just works. All you have to do is to declare your dependencies, and the framework will figure out how to invalidate what needs to be invalidated. And so if you modify the right-hand side records, it determines that the ones in the middle who are connected to that one will have to be recomputed as well. And if those are supposed to be, the value is no longer valid, therefore the ones that depend on those ones are no longer valid as either. Okay? And so what happens is that when you modify the one on the right-hand side, the other ones, they're automatically either invalidated, or actually we can sometimes even prepare their computation. So the way it works is, if the field, So the simple case is that the field never appears, the computed field never appears in database. It's a pure in-memory thing, okay? What happens is that the value is in cache, if computed. All we need to do is to just invalidate that value from the cache. And so the next time you access that field on one of those records, you'll have a cache miss because there's no longer any value in cache, or the value that's there is no longer valid. And because you have a cache miss, the RM automatically kicks in and say, oh, then if you have a cache miss, in this case, you have to compute the value. And then the result will be in the cache. So that's what happened with fields that are not in the database. But we can actually declare the field and say, by the way, put the result in the database. So it's going to be a regular column. And the result of the computation will be stored in the database. So somehow the database becomes the cache now. And so what happens in this case is when you determine that this field value, record's value, the value of a field for a particular record is no longer valid, you mark it to be recomputed. You recompute it when it's needed. So if you access that one a bit later in the process, in the code, you will trigger its actual recomputation, or potentially at the end of the request, just before ending your SQL transaction, you will force the recomputation of those fields so that you can update the database to the value it's supposed to have. And this happens without the developer having anything to do. It's an extremely powerful tool, and it enables actually to shorten our codes, and those data flow dependencies, we only have to declare them. The framework does the rest for us. There's a lot of automation being done under the hood. And it even works in the user interface. So when you define a view, a form view, let's say, so you're in the web client, or a graphical user interface, you're starting editing some record, so you're changing a sales order or a contacts form, something like that. If you have in that form view some of the fields that are actually computed, declared as computed, and you actually modify another field, and that field is actually a dependency of the computed one. When you modify that field, in fact, the user interface part already knows that this guy is a dependency of something else in the form. And it makes automatically a callback to the server to get the recomputation done as with the data that's in the form. So you could somehow preview the value of the computed field before you actually save and commit your changes of that to that record, for that record. And again, the developer doesn't have to do anything for that to work. It's automatic. It's all done for you. Actually, in the past, when I started with Odoo, we've made since the RM evolved quite a lot. But when I was there were already computed fields, but the form view, you had to manually add some code for the computation to take place. And basically, you had to duplicate the code for, let's say, the regular code recomputation and the form view recomputation. They were different, really different pieces of code. Nowadays, they're combined. It's only one source of code. So my point was, it's not always worth it to make your own framework. Basically, one of the advantages of that framework is that it gives me a salary, it gives me a job, right? But the point is that we need those extra features, otherwise we wouldn't be as productive as a whole developer team. These really somehow gives us kind of a leverage for development. And so in this case, it was worth having our own framework. And the other advantage is that if we wanted a new feature, well, we just have to develop it. We don't depend on a third party. So sometimes it's worth it. Not always, but sometimes it's worth it. And that completes what I wanted to show you.